This is video number 3, the final video on the practice final. We're starting with number 28 and finishing it up. Number 28 says solve using the quadratic formula. And previous questions, I did it both methods, the quadratic formula and factoring. As you can see, these are decent answers. There are no square roots involved. So technically, you should be able to factor this, split it, and solve it if you really wanted to. But since they're asking us to use the quadratic formula, that's what I am going to do. Let's start by labeling A, B, and C. This is A, this is B, this is C. The A value is 2, the B value is -5, and the C value is 12. Let me also jot down the quadratic formula. X equals -b plus or minus the square root of b squared minus 4ac all divided by 2a. And we're going to replace those A, B, and C values with parentheses so we could easily plug in the numbers. So let's plug in our A value of 2. That'll go in right there and right there. Let's plug in our B value of -5. That'll be right there, -5 and -5. And what about that C value of -12? That goes right there. Okay, so whenever we do the quadratic formula, it's pretty simple to begin by changing those minuses to plus. We also have 2 times 2, which is 4. So we so far have +5 plus or minus the square root of the discriminant, which we're about to find out, all divided by 2 times 2 is 4. All right, so let's work on the discriminant, yeah? Let me highlight it. What is 5 to the second power? That is 25. Okay, so on the side, I'm going to put 25. And then I need to work on this part. We have -4 times 2. -4 times 2 is -8. And -8 times -12 is +96. So I hope we understand that. And I recommend using a calculator if you're not too comfortable with multiplying. So use a calculator. You have 25 plus 96. That will become 121. So this 121, this inside value is 121. The discriminant is 121. And that works out beautifully because the square root of 121 is 11. So what we really have here is 5 plus or minus the nice beautiful number 11, all divided by 4. And of course that means, that means that we get 2 answers right there. We have a positive situation, 5 plus 11 divided by 4. We also have a negative situation, 5 minus 11 divided by 4. So what is 5 plus 11? That's 16. And 16 divided by 4 is 4. That's one answer. Then 5 minus 11, that's -6. And -6 divided by 4, you can't really do that. If it were a -8 divided by 4, it'd be -2. But right here, 6, you cannot divide by 4. But you could reduce this fraction, and it'll become -3 halves if you reduce by 2. So the 2 answers are +4 and -3 halves. And you could clearly see that it's right there, +4 and -3 halves. There is your answer. Let's move on to question 29. This one is like ridiculously easy because they're just asking you to identify the A value, the B value, and the C value for the quadratic equation. Now, what you need to know is that it needs to be set equal to 0. Your quadratic trinomial, your standard form quadratic trinomial, ax squared plus bx plus c, must be set equal to 0. So first, you need to subtract 12. Subtract 12, which you can't really combine it with any other term. They're not like terms. So what we have here is 2x squared minus 7x minus 12. It does equal 0. The A value is 2, the B value is -7, the C value is -12. So that would be the A value 2, the B value -7, and the C value -12. That's it. That is your answer right there. Too easy. Moving on to number 30. Numero 30. Okay, it says use a quadratic formula. And yeah, for sure we're going to be using the quadratic formula because we see these answers that have square roots in them and it's over 2a, right? So we definitely are going to use the quadratic formula. This answer says no real solution. What would that mean? That would mean that if you happen to end up with a negative inside your square root, if your discriminant is negative, then you know you get imaginary values, so that would be a no real solution. Let's find out what we get here. Once again, let's zoom in and let's use the quadratic formula first by identifying that the A value is -1, that the B value is -3, and that the C value is +14. Let's write our quadratic formula again. There it is. And we're also going to rewrite the quadratic formula again with parentheses so we could easily plug in these values. So let's plug in the A value of -1 down here and up here. Let's plug in the b value of -3 right there and right there. And the c value of +14 is up there. All right, so again, it's super easy to change the minus to plus if you happen to have two minuses right there. And it's super easy to multiply 2 times -1. So what do we have so far? We have a +3 plus or minus the square root of, I don't know yet, but on the bottom we have -2. Really easy. So let's begin by working on the discriminant. We have a -3 squared. That's really a +9. I'm just going to jot a 9 down right here. And then how about -4 times -1? That's +4. And then +4 times +14, that's really +56. And again, if you're not too sure about that, please use a calculator. So we now have 9 plus 56. That will be 65. And that is the value inside the discriminant, inside the square root. The discriminant value is 65. Okay, so let's work on this. We have a 65 in here. Now the question is this. Well, if you look at your answers, you'll notice that there is no answer that has a 60. Oh yeah, there is. It's right there. The square root of 65. See, my idea was to try, so it looks like this is our answer, but what you're supposed to do is try to simplify the square root of 65. It's not a perfect square number. That would be nice if this were a 49 or a 64. It's not. So maybe you could break it down with multiplication to get a perfect square number. So how could you do that, especially if you're not too good at multiplication? You could just say, think of the perfect square numbers and try to divide 65 by 4, for example. So if you go 65 divided by 4, it's not going to work. If you try 65 divided by 9, it's not going to work. 65 divided by 16, it doesn't work. 65 divided by 25, it doesn't work. You cannot break down 65 to become a perfect square number with multiplication, all right? So that's as far as it goes. So that is our answer right there. This is our answer, which means this guy is our answer. But keep in mind that many times you're going to end up with something like the square root of 20 instead of the square root of 65. And right there you will be able to break it down to like 4 times 5 and then split the root. And then that'll become 2 square root of 5. But anyway, that's not the case in this case right here. The square root of 65, you can't do anything with it. It stays. There's your final answer. There's another one where we're going to use the quadratic formula. However, in order to identify a, b, and c, you need that quadratic trinomial to be on one side of the equal sign and set equal to 0. So I will begin by moving some things around. Let's move this 5x over by subtracting it. It'll cancel out. Subtract it. You can't really do that, so I'm just going to leave it. And I'm also going to subtract 3 and subtract 3. That'll cancel. So this is what I have. I know it's kind of ugly. I apologize. I did 2 steps in one. I have 7x squared minus the 5x minus the 3. Right? All I did was, I probably should have done 1 step at a time. Subtract 5x, you'll have 7x squared minus 5x equals 3. Then you subtract 3, you'll have 7x squared minus 5x minus 3 equal to 0. And here's your quadratic trinomial. Your a value is 7, your b value is -5, and your c value is -3. So they want us to use the quadratic formula again. Here's the quadratic formula. Let's rewrite it with parentheses. And let's plug in our b value of -5. It's going to go right there and right here. And let's plug in our a value of +7 right there and right there. And finally the c value of -3 right over there. So once again, the minus changes to plus. The 2 times 7 is 14. So far we have +5 plus or minus over 14. We have the square root, and we're going to have our discriminant inside here once we find out what it is. So let's do 5 squared. -5 squared. -5 times -5 is +25. I'm going to write it up here, 25. And we have -4 times 7 times -3. If you use a calculator, that'll be a positive what? What's that going to be? It's going to be a positive 84. Again, use a calculator so you don't make mistakes. So that will be 84 plus 25, 109. So inside my square root, I will have the discriminant 109. Okay. Now the question is, could you simplify the square root of 109? Like, could you break it down to 4 times something so you could split the root? Could you break it down to 9 times something? Who knows? I don't even know. If you try to use a calculator, by doing 109 divided by 4, it doesn't work. How about 109 divided by 16? It doesn't work, right? It's not going to work. 109 is as far as it goes, right? 109 divided by, pick another one, 36. Nope, doesn't work. So use a calculator and try to divide by perfect square numbers. See if you could actually break it down. In this case, you cannot. So the final answer is right there. 5 plus or minus the square root of 109 divided by 14. And I believe that brings us to the last question on this practice final. It says use the graph to determine the solutions. I really, really hope that we remember from quadratic equations from the section that the solutions are the same thing as the answers, as the roots, as the zeros, as the x-intercepts. All of these phrases mean the same thing, the answers, right? So if they graph it for you, by the way, on any quadratic equation that they tell you to solve, you could technically graph it on Desmos or anything and see where they cross the x-axis, and if it's at decent values, you'll be able to just write down your answer. Like right here, these are nice, decent values. Where do they cross? They cross at +4 and at +7. So that must mean, because the x-intercepts mean answers, that means that your answers are +4 and +7. And that's it. That's your answer right there. Okay? So that's about it, guys. I hope you were able to understand the questions that I explained. Good luck on the final.